Good morning, everyone. Welcome back. If you hadn't noticed, we had a last-minute schedule swap, so this talk will be double agents, not AI as a service. If you're interested in AI as a service logging, that will be in the other room. Please feel free to go. Nobody will be offended, I promise. Before we begin, we'd like to, as always, thank our sponsors who make this entire event possible. And particularly, we'd like to thank our silver sponsor, Sysdig. So please go give them a talk, chat with them out in the hallway. And with that, we'd like to introduce our next talk. This will be a remote presenter, Double Agents, Exposing Hidden Threats in AI Agent Platforms with Michael Katchinskiy and Hagai Kestenberg. So please give them a welcome.
Hi, everyone, and thank you for joining our session, Double Agents, Exposing Hidden Threats in AI Agent Building Platforms. We're happy to be here and sad that we couldn't make it physically to the conference. In this session, we'll talk about the risks in agent building platforms, and we'll see how attackers can access and exploit agents created using these platforms. So first, let me introduce ourselves. I'm Michael, and together with me, Hagai. We are security researchers from the Microsoft Defender for Cloud research team. We mainly focus on cloud native and Kubernetes threat protection, and recently we gotten into AI security as well. And on our agenda for today, we'll start with an overview about AI conversational agents and search agents to make sure that we are all aligned. Then we'll see what does it take to build an agent via a typical building platform. Next, we'll show you how we were able to access agents we don't own and bypass a restriction mechanism in Vertex AI platform. And finally, we'll talk about mitigations and present some best practices. There are many types and definitions of AI agents, and in this session, we'll focus on customer-facing AI agents, specifically conversational agents. To see what sets them apart, let's walk through their key attributes. So interactions with conversational agents happens through a natural language chat when user sends a query or a request. These agents cover a wide variety of roles, from customer support to personal voice assistant. Creators can tune agents' tone and persona to match the brand, and they can execute multi-step goal-oriented workflows that begin with an open-ended request. They preserve context between interactions, and a good example could be an assistant on a clothing website that helps you find items matching your style and search them in stock. And by contrast, non-conversational agents can rely on a closed set of commands. They are built to perform a single task, and they activate only when triggered by a schedule, a button press, or a system event. And a good example would be a job that is triggered automatically, but involves an LLM in the process. So essentially, conversational agents are chatbot, but much better. And there are many platforms for creating these agents, and as expected, all major cloud providers have launched their own offerings. For example, Google offers Vertex AI Agent Builder, Microsoft has AutoGen and Copilot Studio, Amazon provides Bedrock, and IBM offers Watson X. And in addition, many independent companies have developed their own platform as well. And like everything related to AI, the pace of development of these platforms is amazing. More than 50 have already launched, and most of them just in the past year. With such a rapid rollout, we can assume that security was not necessarily the top of mind. And in addition to that, most of the platforms are no-code or low-code, designed to be accessible to everyone. That means even non-technical employees can deploy AI agents, bringing all the risks and responsibilities that comes with it, and we'll circle back to this later. And in general, the process of creating an agent using these platforms includes few basic steps. Users need to choose a base model from the catalog, like GPT, Claude, or Gemini. Next, they will define the agent purpose and guidelines by writing a system prompt that describes what to do. Then they will connect data which is relevant to the agent. For example, it could be your company's guidelines or a database that contains information about available stock. And they will connect tools and plugins, like giving it the ability to read and send message on your Slack or Teams channel. And finally, they will need to publish the agent, which is the part that we'll be focusing on today. And of course, every platform has its own unique features. This is just a high-level summary of the common foundations shared across these platforms. And now that we've explored the leading platforms and understand the process of creating an agent, some of you are probably wondering, is this even secure? And we'll focus on how these agents are published and integrated with other systems. Each platform handles the details a bit differently, but the underlying concept is pretty much the same. And what really caught our attention was the platform's website integrations. Agents can be embedded with a single HTML snippet supplied by the platform itself. The snippet usually contains only a unique identifier, no tokens or authentication flow are required, just a static ID. The simplicity is alarming, and that's why we launched our research. And now, we will switch to Hagai.
Thank you, Michael. Now let's see this in action and dive into our research findings. Although our findings are applicable for many platforms, we will demonstrate them on GCP Vertex AI, which is one of the leading platforms in the industry. So let's start. So we are now with the Vertex AI platform creating our first agent, and we can see that as first step we need to choose our agent type. Now Vertex offers several agent types for different purposes, but in this session we will focus on two of them. The first type is search agents, which allow users to build natural language search engines over their data, supporting a wide range of data sources. And the second type is conversation agents, which are designed to interact with users through natural language by providing answers or performing actions based on the agent instructions and the user input. So let's start with the conversational agent. We are now at the agent setting page. This is where I can define its purpose, its tools to connect data sources, and basically fine-tune how the agent will behave. And once I configured everything, the next step is publishing the agent, say to make it available in my company's portal. So here you can see the publish agent button, and after clicking it, a window appears asking me to choose how the agent should be published, with Anonymous API or using Authenticated API. Now, that's an interesting decision point. Let's take a moment to discuss it, and we will do it by examining 3 agent access models and what scenario they serve. So the first access model is agent with anonymous access, meaning it doesn't require any authentication. And in many cases, anonymous access is intentional, especially for customer-facing agents that don't handle sensitive data. For example, a chatbot agent in e-commerce website that's designed to assist users with the store catalog. The second one is the hybrid model, in which the agent itself is still configured as anonymous, but hosted on an internal website or a platform with authentication mechanism. For example, an HR assistant agent embedded into a company's internal portal that requires employees to sign in. And the third access model is the auth required, in which every interaction with the agent requires authentication. But for now, we are going to focus on the anonymous and hybrid access models, in which the agent itself is anonymous or configured with public access. So back to our published settings, we saw we can deploy our agent with anonymous API or using authenticated API. But in search agents, which we introduced before, Vertex enforces an additional control. Even if you choose to allow public access to the agent, you still have to explicitly define the allow domains that could access the agent. And this requirement doesn't apply to the conversational agents, only to the search agents, and I think it makes sense, given that search agents are likely to work with more sensitive data, or at least with internal data. And once I confirm the anonymous API, regardless the agent type, Vertex provides me an HTML snippet that I can embed directly into my website in order to use the agent. And here is where things get interesting. Take a look at the snippet. You will notice 2 identifiers, the project ID and the agent ID. And these are the only unique identifiers needed to interact with the agent. Now, if I will take this HTML snippet that Vertex provided me and drop it into a basic HTML editor, you can see that my agent is alive and I'm able to interact with it. So, a quick summary. We covered the access models for Vertex AI agents. For an anonymous user to interact with a search agent, it must be configured with public access, and the user's domain must be explicitly allow listed. And for conversational agent, enabling anonymous access is also required, but the allow domain restriction is just an option. Okay, so now that we got familiar with the HTML integration Vertex provides, let's see how attackers can hunt agents and what they can gain from it. And to answer this, let's walk through a practical example of an attacker methodology to achieve that. And as always, let's start with reconnaissance. Well, since Vertex provides us a ready-to-use HTML snippet, we thought that would be a great place to start. Naturally, we thought about platforms like GitHub, where developers store and share their code. So we began searching on GitHub and SourceGraph for websites that embedded Vertex conversational agents by searching for the HTML snippet patterns and keywords, just like the one shown here. And the results came fast. On GitHub alone, we found hundreds of public repos with Vertex HTML snippets, each one exposing its agent ID and project ID. We believe the reason we are seeing so many exposed agents is that many developers assume their anonymous agent is safe only because it's embedded within an internal site or a site with authentication mechanism. But here is the catch. Those protections don't apply at the agent level. And if attackers find their project ID and agent ID, they can bypass those layers and interact with the agent directly. Let's see how it happens and what attackers can do with all these results. So basically, attackers can take the HTML snippets they found on GitHub to plug them into a simple HTML editor and immediately start trying interacting with the agents in order to see if they're anonymous or have any domain restrictions. You would be surprised that using this simple technique, within just a few minutes, we were able to access multiple anonymous agents and retrieve sensitive data, like the example you see here, where an agent revealed the company's financial secrets, all without hitting any access controls. So that's nice. Within a few minutes, we were able to access organization internal data using the anonymous agents. But let's raise the bar a bit. Earlier, we mentioned that search agents require specifying allowed domains that could access the agent, even when an anonymous API is configured. And as a developer, I might think, okay, my agent may be anonymous, but it's still protected, because only users accessing the agent for my domain, which requires them to log in, can reach it. But is it really the case? Let's take a closer look at what attackers can actually do with search agent identifiers. So again, a quick search for the HTML snippet patterns on GitHub will return hundreds of search agent identifiers. For example, let's take a look at this agent snippet that caught our eyes, and when we tried to interact with this agent by simply copying the HTML snippet from the repo to our editor, we immediately got an error. And that message indicated us that our domain wasn't on the allowed list. Now that makes sense, no one is going to add a random HTML editor as an allowed domain. But as I said, something about this agent caught our attention. It seemed valuable, so we decided to dig a little deeper. And while browsing the repo, we noticed that a specific domain kept popping up. Let's call this domain hrportal.com. So it's reasonable to assume that this domain was included in the agent's allowed domain list. And now the question becomes how we can impersonate this domain in order to interact with the agent. So we started the impersonation attempt with the basics. Using burp, we attempted to manipulate the HTTP request we sent to the agent by replacing the original referrer in the request headers. Unfortunately, that didn't work, and we still got the unallowed domain error. So we took a different approach. We edited our local etc hosts file, which is a system file that maps domain names to IP addresses. And basically, when your computer looks up for a domain name, it checks this file first before querying DNS servers. So it's a great way to override domain resolution locally. So we use this trick to map the suspect allowed domain, hrportal.com, to localhost, and then we created an HTML file containing the HTML snippet from the repo, and spun up a simple HTTP server to host the file locally. Now, when we open the browser and navigated to hrportal.com, it routed us back to localhost to our local HTML file, and we can see we are effectively spoofing the domain. And this time, when interacting with the agent, we can see it worked. We can see no errors. We were basically able to bypass the agent's allowed domain feature and freely interact with the agent as if we were coming from the original trusted domain. So that's cool, we have an initial access, and now that we are able to interact with the agent, we are moving to the discovery phase. In this phase, we want to gain knowledge about the agent tools and connected data sources so we can know if it's valuable for us as attackers. But we don't need to work that hard. For example, here you can see a question for the agent, basically a prompt, that reveals all the agent tools, knowledge bases, and even other agents that connected to it. And this helps me as an attacker to understand if it's valuable for me. And after we gained knowledge about the agent, here is the fun part. All we left to do is kindly ask the agent to share the data it holds. We were able to retrieve numerous sensitive responses from both conversational agent and search agents. In many cases, the agents even returned the content of documents and their direct links, even though we weren't able to access the provided links directly. Within minutes, we uncover hundreds of agent identifiers, some fully anonymous, others with the allowed domain feature that we were able to bypass. And from there, it's just a matter of evaluating which agents are valuable and extracting the data easily. And this is exactly what we call agent hunting. But data exfiltration isn't the only threat. In addition to data exfiltration, attackers can intentionally overload AI agents leading to technical disruptions such as denial of service attacks or simply driving up costs, since these agents often scale automatically and can be expensive to run. Thank you, and back to you, Michael, for Google's disclosure.
So we contacted Google to highlight that attackers can bypass the allowed domain restriction, something that customers may rely on to protect their agents. Google replied that they do not treat the allowed domain feature as a security control, and they also stated on the documentation that setting the authorization mode to public access will allow anyone to access the agent. That's the reason they do not view the bypass as a vulnerability. And although using a JWT or auth-based authorization remains the recommended best practice, the allowed domain settings still serves as a fallback layer of defense when an agent sits behind a private or authenticated website and strong controls are not in place, just like the example displayed here. And going back to the beginning, we said that different platforms have many concepts in similar, and indeed, many platforms offers a web integration using HTML snippet with static identifiers, and because of that, they are also at risk of being targeted. For example, here you can see the web integration offered by IBM Watson X, and another example from the BotPress AI platform. With a quick search on GitHub for the patterns mentioned here, we found thousands of exposed agent identifiers. And you might be thinking, are you guys going to talk about Microsoft? So the answer is yes. In Microsoft Copilot Studio, the case was a little bit different than what we talked about here. A demo website is created automatically when creating an agent, no matter if and how you choose to publish your agent. A link to this website will always exist. And there is a research published by Dora Tias that demonstrates how these demo websites of external users could be found and accessed. I'm attaching a link to the research in the presentation, and I really recommend you to read it. So let's sum up what we've seen so far. We examined the rise of conversational AI agents, how they are built by dozens of fast-moving no-code platforms. A key takeaway is that these agents are often embedded on websites with a tiny HTML snippet containing only a static ID, making deployment trivial but sparkling serious questions about exposed identifiers and anonymous access. So, how do we turn those red flags into an action plan? So we need to minimize public exposure and avoid public endpoints whenever possible. We also need to treat every agent identifier as a secret. In HTML snippets, these identifiers act like credentials. Never commit them to public repos and include their pattern in your secret scanning pipeline. Next, and this is a difficult one, you need to maintain visibility over what's running. Keep a living inventory of AI platforms, agents, and data they touch. And finally, educate every user, technical or not. When anyone can spin up agents in minutes, awareness is your first line of defense. Thank you for listening.
Great. Thank you very much. As always, we'll have questions in the Slack for anybody who's remote or does not want to ask them live. If there's anybody here who wants to ask questions, please just raise your hand. So I'll start off. I mean, in some of the takeaways you talk about monitoring, but can you get a little more about like how the different platforms allow guardrails to prevent anybody from creating these, and then how do we as defenders test what they go and implement various types of change control to ensure that we don't expose ourselves to these risks?
Yeah, so can you hear me, right?
Yes.
Okay, so I'll start. So first of all, we'll need to do a few things. Each platform offers a different type of guardrails. For example, I think that Vertex AI offers some kind of a quota that they have like 1,200 requests per minute from a specific sessions, so they prevent exhaustion and agent overloading. So that's for the first question. And then again, there are also many platforms that the admins of, let's say, the tenant or the Google project can actually disable unauthenticated mode for all of the users. And then it just won't be possible to create these like agents with these kinds of unauthenticated way.
Thank you. Other questions in the room? All right. Come back here.
Have you come across any of these platforms that have guardrails already in the way that, Google Docs allows you to prevent public sharing of certain documents, and I guess O365 has the same? Like, are there any of these agent platforms that have more security control in the current time, or are they all kind of at the same level of maturity?
So we explored Microsoft, Google's, and WordPress, and some other. They were basically mostly the same. We weren't looking a lot into guardrails. I mean, we were mainly focused on the authentication method. But I haven't seen like something in specific. I mean, I think that the authentication mode is like their way of saying this is how we prevent someone from accessing. But again, every company was developing their own platform very fast. So I think that things have changed since we did our research a few months ago.
All right. Can you talk? One of the things you also mentioned was denial of wallet style activities or denial of service. Can you talk a little bit more about what those risks are, how the users get charged, and people's vulnerabilities to excessive usage of these public agents?
Yeah, so I think these agents are expensive to run. So I think for organization, it's about choosing the platform with usage limitations or built-in usage limitations, where you can monitor the usage of the agents and limit the access to it and the usage. So this way you can be in awareness for the financial issues as well.
And I also mentioned that that Google has their own like resource, like a quota for each session, which could also be a user can open multiple tabs and some kind of a bypass it. But then they also offer their own products, such as I think it's called Google Armor or something, which will allow you to put better quotas to prevent such kind like denial of wallets attacks.
All right, thank you. Any more questions in the room? All right, can we have one more round of applause? Thank you, Michael and Hagai.
Thank you, everyone.